Hi guys, Assalamu alaikum. I hope you are all well and having a good day. So basically today we will solve the most recent Physics Unit 5 paper, the January 2025 paper. So without wasting any more time, let's start. Now here in section A, the first question says a main sequence star evolves into a red giant star. Which row of the table gives the change in diameter and the change in surface temperature when the star evolves? So basically they're talking about the diameter of the star and the surface temperature of the star. Now we know when the main sequence star evolves into a red giant star, the main sequence star was like this, the red giant star, as the name suggests, it is giant, right? So it will be, let's say it will be this big. So if something becomes bigger, okay, if something gets bigger, we know its diameter will increase. So its answer will be either C or D. Now let's have a look at the surface temperature. Now, as a main sequence star becomes a red giant, its outer layers expand, right? Its outer layer has expanded right here. Its outer layer has expanded. As its outer layer has expanded and spread out over a much larger surface area. Now it has a much larger surface area, right? Now, as both of them have the same energy, because the same energy is now spread out over bigger surface, the energy this main sequence star had was in a smaller area. Now the energy that this red giant has is in a more bigger surface area. The energy has spread out, so now the surface temperature will drop, making the star cooler on the outside, even though it has grown bigger. So basically our correct answer will be C, because the diameter has increased and the surface temperature has decreased, because when the surface area increases, the same amount of energy is now spread out over a large surface area. So that's why now the surface temperature decreases. Now in the second question, it says ductile materials can be used in buildings to reduce the amplitude of forced oscillation during an earthquake. Which of the following is the reason that ductile materials are used? Now the first one says these materials are stiff. So basically this has nothing to do with that. Basically the ductile materials are used because ductile materials absorb the energy, and when they absorb that energy they don't give back that energy. Okay, they do not return that energy. These materials are strong. Strong has nothing to do with the absorption of the energy. And the C part says these materials deform elastically. If it has deformed elastically, then it would have given the energy back, because we know elastic deformation means it can return to its original position, right? So it will give off the energy that he has taken. But when something deforms plastically, it doesn't give off that energy again. It doesn't return that energy. That energy is completely absorbed. So our correct answer will be D. Now the third part, it says there is an electric field around a point charge and a gravitational field around a point mass. Which of the following is not correct? It is saying which is not correct. Now with question in option A, they have given both fields are radial. Yes, both of them are radial. It's correct, because we have seen that both of are radial, right? This is a radial field line. This is how the radial field lines looks for both the electric field and the gravitational field. Both can produce attractive forces. Yes, both of them can produce attractive forces. Now the C part is not correct, because it says both of them can produce resistive forces. No, they cannot produce repulsive forces, because though electric field can repel, because the positively charged particle can repel another positively charged particle, but basically there is no repulsive force between the masses. Okay, the charged particles can repel them, but the mass are always the gravitational force between the masses are always attractive. So this is going to be our answer, because this is not correct. Now the next part says both fields produce forces that obeys an inverse scale law. Yeah, it is correct as well, because F is equals to gmm by r squared, and F is equals to k theta 1 k theta 2 by r squared. So F and the r squared is obeying an inverse square law. Now the next question, it says the diagram shows the binding energy per nucleon varies with the number of nucleons. The position of the three isotopes P, Q, R are marked on the curve. Which row of the table lists the isotope from the least stable to the most stable? We know the stability depends upon the binding energy per nucleon, right? The higher the binding energy per nucleon is, the more stable it is. Now here we can see Q is at the top part, so it will have the most binding energy per nucleon, it will be more stable. Now the R is the second one, so it will have second most binding energy per nucleon and it will be second most stable. And the P is the least, has the least binding energy per nucleon, so it will be least stable. So our answer will be from least stables to most stable. So P is the least, R is the second least, and Q is the most. So our correct answer will be B. So basically your stability depends upon the binding energy per nucleon. Okay, the higher you are, the more binding energy per nucleon you have and the more stability you possess. Under the number 5, it says astronomers use trigonometric parallax to determine the distance of the stars. Which of the following must the astronomers know? So basically this is a very easy question. The only thing that the astronomers must know is the distance between the sun and the earth. The answer will be C, but I will explain it, don't worry at all. If you look at this picture, you gotta be able to memorize, you gotta be able to actually draw this one. Okay, you gotta be able to draw this one, or you have to memorize this parallax method, 4 marks 5 marks question, which is a frequently asked question. I have provided that question in my FAQ video. If you guys can go through my common questions, my common important and difficult questions video, which I will put in the description box of this video. You can go through that, where I have discussed a lot of frequently asked questions, probably all of the frequently asked questions, as well as some difficult and important questions as well for your exam session. Now here, for this parallax method, the scientists should be able to know the distance between the sun and the earth. Basically this distance, okay, the distance between the sun and the earth must be known. So that's why we are saying that the distance between the sun and the earth must be known. Otherwise they won't be able to actually use parallax method or the trigonometric parallax. Then the number 6, it says a container is filled with a mixture of two gases. All right, that's great that it was filled with two gases. The root mean square speed, sorry, the root mean square velocity of molecule in gas X is twice the root mean square velocity of molecule in gas Y. The temperature of the mixture is constant. Okay, the temperature is constant. This is a very important information, that the temperature is constant. Always annotate while solving the paper, just like the way I'm doing. Now it says what is the ratio of mass of molecule of gas X by mass of molecule of gas Y. Now they were saying that it was twice the root mean square. So basically the root mean square speed of Y is twice the root mean square speed of X. You will have to keep that in mind as well. Now there is a formula which is half mc square is equals to 3 by 2 kT, right? This is basically the kinetic theory formula for which includes the root mean square speed, right? Half mc squared is equals, it will look like this actually, just give me a little bit of time. So it will actually look like this, right? Let me make it a little bit of change. This is how it looks like that. Half mc squared is 3 by 2 kT. Now here both of them, the temperature is constant. As the temperature is constant, and we know this k is also constant, and 3 by 2 is going to be the constant as is a constant as well. So this as a whole is a constant. So as all of them are constant, okay, we can say for X and Y, the half mc squared, the kinetic energy is going to be the same. Okay, we can say both of them will have the same kinetic energy. So we can say half m c, let's say this is for Y, squared is equals to half m c squared of Y. We can write it down like this, right? And we can also remove this half, because both of that include the half values, right? Both of that include the half values. We can include. Now, as the question suggests us to figure the ratio between the mass of X and the mass of Y, this was the mass of X and this was the mass of Y, right? We can make a ratio right here, that mass of X by mass of Y is equals to, this C will be in the numerator and this C will be in the denominator, right? So we can write it like this, C squared divided by C squared. This one was for Y, this one was for X. Now here they have said that the root mean square velocity of X is twice the root mean square velocity of Y. So if Y is 1, that X is going to be 2, right? So we can write it down like this, 1 squared divided by 2 squared is equals to mx by my, which can be written as 1 by 4. So the ratio of mx by my is equals to 1 by 4, because the root mean square speed of Y was 1, and if the root mean square speed of y was 1, then root mean square speed of x will be 2, because 1 was twice the other one, and this whole portion means the root mean square speed, right? So the answer will be A, because the ratio is 1 by 4. Hopefully you guys have understood it completely. Now moving on to the question number 7, it says the value of the Hubble's constant H naught was initially was initially estimated to be 1.5 into 10 to the power minus 17. This was the initial one. Okay. Using this initial value, the age of the universe is T. Alright. Scientists now estimate H naught to be 2.1 into 10 to the power minus 18. So this is the new one. Alright. Which of the following is the age of the universe using this value of H naught? I mean this value of H naught, which they are referring to. Alright. So basically now they are asking the age of the universe. So basically this H naught is the new H naught, right? This is the new H naught, and this H naught was initially means it was the old H naught, right? And this time is the old time, I mean the time using this particular old H naught, and now they're asking for the age of the universe. So basically they're asking for the T new using this new H naught value, right? This is what they're saying. So we know one thing, that is time is directly proportional to 1 divided by h naught, right? And if you write t is equals to k divided by h naught, right? If we remove this directly proportional sign, it becomes t is equals to k divided by h naught. Now we know this particular time, and we know this particular h naught as well, right? So we can write t old is equals to k divided by h naught, I mean this h naught, which was 1.5 into 10 to the power minus 17, right? Which can be written as k is equals to t old into 1.5 into 10 to the power minus 17, right? This is the value of the k that we have figured out. Now let's derive this particular formula for t new, I mean this t new. So if we write t new is equals to k divided by h new, we know t new is equals to this k is going to be this one. Okay, so we can write um, t old into 1.5 into 10 to the power minus 17 divided by the h new, and the h new is given as this value, which is 2.1 into 10 to the power minus 18. Now this can be written as t new is equals to, we know t old was referred as only t, right? Initial value was referred as only t, so we can write them down as t into this division. So if we divide both of them, it will give us a value of 7.1. So we can get that t new is 7.1 into t. So our correct answer will be D. Alright, now let's have a look at this as a whole. Hopefully you guys will understand. If you guys have any question in this part, please feel free to comment. I will explain them again to you guys. Hopefully it was easier to understand. Now moving on to the question 8, it says a pendulum is made by a light paper cone to a thin string as shown. Alright, the pendulum is displaced and set into oscillation. Plasticine is then added to the paper cone to increase the mass of the pendulum. So basically you have increased the mass of the pendulum. You have increased the mass of the pendulum. The pendulum is set into oscillation again. So after increasing the mass, they have set the pendulum into oscillation once again. Which of the following is correct for the paper cone with plasticine? Now one thing that we guys will have to understand is when you have increased the mass of the pendulum, now it will be oscillating. Now as you have increased the mass of the pendulum, I mean the paper cone, as you have increased the mass of the paper cone, now as the mass increases, the kinetic energy also increases, right? We know kinetic energy is equals to half mv squared. So as the kinetic energy has increased, now paper cone will be moving with more kinetic energy. The paper cone will be moving with more kinetic energy. Now as the paper cone will be moving with more kinetic energy, it will take more time for the resistive forces to decrease the oscillation of the paper cone to zero, right? As the kinetic energy is increased, now as the resistive force air resistance is constant, now to decrease that higher kinetic energy, it will take more time for the resistive force air resistance to decrease the oscillation of the paper cone. So basically the amplitude of oscillation decreases more slowly because it takes longer time for the air resistance to decrease the oscillation of the paper cone. Now here is the explanation that I have written for you guys in a summary so that you guys can remember this one. This is basically the summary. Here we can keep it right here, basically right here, that as there are more mass there will be more kinetic energy and resistive force will take longer to stop it, so the amplitude decreases slower. Okay, now moving on to the question number 9, it says due to tidal action the moon is slowly moving away from the earth. As the moon moves away from the earth, the gravitational force between the earth and the moon changes, and the gravitational potential energy of the moon also changes. So something is moving away from the earth, and we know according to the gravitational force formula, which is gmm by r squared, if something is moving away from the earth, its radius is increasing from the other one, so the force will decrease, right? The greater you move away from the other one, the greater your force decreases. The force actually decreases. So our answer will be any one between A and B, right? The next part is about the gravitational potential energy. Now we know when there is a difference between, the more the difference is between the two particles, the greater will be the gravitational potential energy between them. Right? If you move something away, the gravitational potential energy actually increases. Let's say you are at the first floor of your apartment, you have certain gravitational potential energy. Now if you move to the fifth floor, your gravitational potential energy increases even more because the height has increased, right? The greater the height, the greater the gravitational potential energy. Basically the gravitational potential energy means your separation from the ground. So as your separation from the ground increases when you move to the fifth floor from the first floor, your gravitational potential energy increases. Like the same way, if the moon is moving away from the earth, it is moving away from the earth, so its separation from the earth is increasing. As its separation from the earth is increasing, the gravitational potential energy also increases. So our correct answer right here will be B, because the gravitational force decreases and the gravitational potential energy increases. Now moving on to the next question, it is a tricky one. It says energy is supplied at a constant rate to a material. All right, that's great to know. The material is initially solid. As energy is supplied, the solid melts to form a liquid, and finally the liquid turns into a gas. The mass remains constant during the heating process. So basically they have said the mass is remaining constant. This graph shows how the temperature changed with time. All right, the temperature change and the time. Okay, the temperature change with respect to time. Which of the following is correct? So basically in each of the all the options, they are talking about the specific heat capacity. They're speaking about the specific heat capacity, and here the time. So basically here, as the time is increasing right here, we can relate this time with energy, because we know, as the energy is increased, the temperature increases, right? As the energy is increased, the temperature is increases. Why? Because we know energy is equals to voltage into current into time. Okay, so energy has been supplied. When you increase the supply of the energy, the temperature of the solid increases. So basically we'll have to supply the energy, and as the time increases, basically the energy increases. So here, as we can see, the time is increasing in the x-axis, and in the y-axis the temperature is increasing. So basically the time is increasing, that means the energy is also increasing. So basically this x-axis can be referred as an energy value as well. So we can think it of like a temperature energy graph as well. And we know there is a formula: energy is equals to mc del theta, right? Energy is equals to mc del theta. We can say energy equals to mc del theta. Now as the question was asking about the specific heat capacity, we can make C the subject. We know mass is constant. So we know that mass is constant, so we can actually remove that part. We can only write energy is equals to C del theta. Okay, now C was something using which the options were. So let's make C the subject. So C is equals to E divided by del theta. Now our graph is the temperature and energy graph. We know to find the gradient, we'll have to multiply y-axis by x-axis, but here it is x by y. So we'll actually reverse them. So it will become del theta by E, which will become 1 by C. The C will become 1 by C. So it becomes 1 by C is equals to del theta by E. Now basically 1 by C depends upon the gradient of this graph. Now we will have to look which three part, there is solid, liquid and gas, which of them has we can see that the gradient of the solid and the liquid, between these two, the gradient of the solid is greater because it is more slanted, right? It is more steeper. So um, so as 1 by c is equals to del theta by e, which means the y-axis by x-axis of this graph, we can write it like this: 1 by c is equals to m, right? Now s, the gradient of the solid is greater than the gradient of the liquid. I mean, the solid is more steeper than the liquid. So we can see that if someone has a greater gradient, its specific heat capacity is going to be smaller. So we can say specific heat capacity of solid will be smaller than the liquid, but here it says the specific heat capacity of solid is greater than the liquid, so this cannot be our answer. The solid is greater than the gas, it says, but here we can see the gradient of the solid and the gradient of the gas is the same because both of them is has the same steepness and the same size, so their gradient will be the same. Both of them have the same gradient, so our correct answer is going to be D, because if someone have the same gradient, there we can write, if someone has the same gradient, we can say 1 by c of gas is equals to 1 by c of solid. So we can say the specific heat capacity of gas is equals to the specific heat capacity of solid. We can say our answer is D, right, if both of them have the same gradient. Whereas this C part says the specific heat capacity of solid is equals to liquid. No, the solid has a greater gradient than the liquid, and the solid has a smaller specific heat capacity than the liquid, so this cannot be our answer. And it says solid is greater than gas, but both of them have the same specific heat capacity because they have the same gradient. So that's how you guys will have to answer this type of questions. Hopefully you guys have understood this part easily. Now let's move on to the section B. All right, so the question number 11 says a mass of 0.35 kg is hung from a spring. The mass is displaced vertically from its equilibrium position and released. The mass oscillates vertically with simple harmonic motion with a period of 0.95 seconds. And an extra mass is added and the period increases to 1.15 seconds. All right, calculate the added mass. So they have asked us to calculate the added mass, the mass that was added, and after the addition of that mass, the time has increased from 0.95 to 1.15. So they are asking us to figure out the added mass. So to figure out the added mass, one thing that we can do is we know the formula of time period, right? The formula of time period is equals to 2 pi root over mass by k, right? We know this time period, we know this mass. This is the time period for 0.35 kg mass, right? And we don't know the value of k, so we can figure out the value of k, right, first. So time period is 0.95 is equals to 2 pi into root over mass is 0.35 divided by k, right? This is how we can do it. Now we will make T the subject. So 0.95 divided by 2 pi is equals to root over 0.35 by k, right? We can take root over into this side, so it will become 0.95 divided by 2 pi squared is equals to 0.35 by k, right? And it can also be written like this: 0.95 squared divided by 4 pi squared is equals to 0.35 by k. Now if we make k the subject, it becomes k is equals to 4 pi squared into 0.35 divided by 0.95 squared. So if we make a value of k, it comes as 15.3 Newton meter minus 1. So this is basically the value of k. Now if we have got the value of k, now we can use this time period value to figure out the mass. So it will be 1.15 is equals to 2 pi into root over mass divided by k, and we know the k is the same for both the values because the stiffness constant remains the same. So it will be 15.3. Now we will just have to make this m the subject. Okay, So this m will become 1.15 divided by 2 pi. This whole will be squared is equals to m divided by 15.3, right? So to make m the subject, it will become 1.15 squared into 15.3 divided by 4 pi squared is equals to my m, and the value of m will come as 0.512 kg. So this is basically the mass at which this time period happens, but the questions said not the mass, it says the added mass. I mean the mass that was added to this 0.35 kg. So this is the mass that has gone for a time period of 1.15, but the question says about the added mass, so we'll have to subtract 0.35 from this value. So mass added is equals to 0.512 minus 0.35 kg, which will give us a value of 0.162. And as most of the values here is in two significant figures, so we will write our answer in two significant figures, so it will be 0.16. The most number of datas are in two significant figures, that's why the final answer will be in two significant figure as well, so it will be 0.16. Now let's head towards the question number 12. The question number 12 says the graph shows how gravitational potential varies with distance r from the center of the earth. Show that the mass of the earth is about 6 into 10 to the power 24 kg. Alright, so they have given us the potential in the y-axis and the radius in the x-axis, and they have asked us to figure out the mass of the earth. We know there is a very common formula, which is v is equals to minus gm by r, right? This is the formula. We have got the radius that we can figure out from the graph as well as the potential from the graph, and then the g is a constant, and we will just have to figure out the value of m. So let's take any corresponding v and r values. So the one that I'm going to pick is going to be this one. Okay, at this point the potential was minus 1 into 10 to the power 7, and the radius was 0.4 into 10 to the power 8. Never ever forget to look at this extra powers. Okay, so if we make m the subject, m is equals to v into r, so it will be 1 into 10 to the power 7, this one 1 into 10 to the power 7 multiplied by 0.4 into 10 to the power 8 divided by the radius, sorry, divided by v into r divided by this g, which is 6.67 to 10 to the power minus 11, given at the back end of your paper. And you guys might ask me, why did I write positive right here? Because this negative was cancelled out by this negative value, that's why it has become positive. So the answer will be 5.997 into 10 to the power 24 kg. We will write it down as 6 into 10 to the power 24 kg. A pan of water is heated on a hot plate as shown. A mass of 0.65 kg of water is boiled away in a time of 1250 seconds. The power of the hot plate is 1800 watt. Calculate the efficiency of the boiling process. They have given us the specific latent heat of vaporization of water 2.26 into 10 to the power 6 joule per kilogram. So basically they have asked us to calculate the efficiency, and we know the formula of efficiency is useful power output divided by total power input, right? This is a very important formula, that efficiency is equals to useful power output divided by total power input. Now here the total power input is the power of the hot plate, right? This is the power of the hot plate, and this is the power that this hot plate will be providing to the pan. And now it depends upon the pan how much it can take and how much output it can give us, and on that output our efficiency will depend. So let's write 1800 right here at the denominator, because this is the total power input. Now useful power output is needs to be figured out by the formula of power. So we know power is equals to work done divided by time taken. So here power is equals to, my work done will be the mass of water that is boiled and the latent heat of vaporization. So it will be 0.65 into this value divided by the time taken, because work done divided by time taken, right? So we can write it down as 0.65 into 2.26 into 10 to the power 6 divided by 1250. So our power output value will be 1175 watt. So this is 1175 watt, right? This will give us a value of, we can actually multiply it with 100. It actually depends, it's your decision whether you want to multiply with 100 or not. I will always multiply. So this will give us a value of 65%. Now moving on, the next part, it says putting a lid on a boiling pan reduces the energy transfer needed from the hot plate to keep the water boiling. So basically when you put a lid on the boiling pan, the only thing that comes to my mind is, let's say I am putting a lid right here on the boiling pan. So what it will happen is, if there wasn't any boiling pan, then the liquid that was vaporized, I mean the liquid that was vaporizing would have escaped, right? The liquids, they would have escaped. The gas would have been escaped. The vaporized liquid, or yes, the vaporized liquid would have escaped. That they have turned into gas and they would have basically escaped. But if there is a lid right here, they won't be able to escape. And this is the answer that we will have to write. Let me bring the answer. So basically this is going to be our answer, that when you put a lid, less steam actually escapes, and so less energy is transferred to the surrounding, because less amount of vaporized gas is going to the surrounding. Now the reason behind putting another 2 points is, actually giving these 2 points will award you the full mark, the full 2 marks. But still I have added few more points, the third and the fourth point, to make you guys understand few more points, because understanding these 2 more points will allow you to grasp few more ideas which might be in need in the later sessions of the exam. So it says steam condenses at the lid. So why does the steam condenses at the lid? Because basically the temperature of the lid is definitely less than the temperature of the steam, right? Because steam has converted into steam from liquid water, and that liquid water was in direct contact with the hot plate, or the hot plate was exerting power on the liquid water. So this steam basically has temperature higher than the lid. So when the steam and the lid is in contact, the steam condenses. It condenses means it returns back into liquid, and when it returns back into liquid, it releases the latent heat of vaporization that it has used to turn from liquid into steam. So it has basically previously used latent heat of vaporization, or the latent heat of vaporization energy, to convert from liquid to steam. Now when it has condensed at the lid, now it is returning that latent heat of vaporization energy to the pan. So at that time it actually releases the energy, and when it releases the energy to the pan, so this energy is going back to the hot water. So when it is going back to the hot water, so the latent heat of vaporization used is less. So when lesser amount of latent heat of vaporization energy is used, we can say the hot plate requires less energy transfer. He actually needs to transfer less amount of energy to keep the water boiling, because less amount of energy has been actually escaping to the surrounding, and a bigger amount of energy is returning. So when the energy is returning, less energy is escaping. So the hot plate needs to do or needs to transfer less energy to keep the water boiling. Now I will be adding one extra explanation right here to make you guys familiar with this thing. The explanation is right here. It says steam takes energy from the water to evaporate, right? And when steam condenses on the lid, it releases that energy. This energy goes back into the pan, warming it and reducing heat loss. The Earth takes 365 days to make one complete orbit of the Sun. Alright, we all know that. Show that the mass of the Sun is about 2 into 10 to the power 30 kg. So they are asking us to figure out the mass of the Sun. Radius of the Earth's orbit about the Sun is this. And they have also given us the time in seconds of 1 year. Alright, so basically one formula that we all know is force is equals to gmm by r squared, right? Force is equals to gmm by r squared. Now you guys might ask me, why am I bringing this mass or this force formula right here? The question has asked me to figure out the mass of the Sun, and why did I bring out the force? The reason is because the Sun has a mass, so does the Earth. So as both of them has the mass, both of them will be exerting gravitational force on each other, right? We know, let's say this is the Earth, and let's say this is the Sun actually, okay, and this is basically the Earth. So so the Earth is actually revolving around the Sun, right? The Earth is actually revolving around the Sun. So when the Earth is actually revolving around the Sun, when the Earth is actually revolving around the Sun, a gravitational force is exerted by the Sun on the Earth and by the Earth on the Sun. So let's talk about the gravitational force exerted by the Sun on the Earth. So this is basically my Sun and this is my Earth. So basically the Sun is exerting a gravitational force on the Earth in this direction. Let's try it like this. It is exerting a force in this direction, and we know as the Earth is orbiting the Sun, it is moving in a circular motion. It is having a circular motion, right? And there must be a centripetal force acting on it, and that centripetal force is exerted by the Sun on the Earth in the form of the gravitational force. So we know the formula of centripetal force. The formula of centripetal force is gonna be mr omega squared right here. The formula of the centripetal force is gonna be mr omega squared right here. And we know the centripetal force right here is actually the gravitational force, right? The gravitational force and the centripetal force. So we can write both of this formula as a whole. So we can write mr omega squared is equals to gmm by r squared. Out of this we will have to just make this m the subject, because this m is the mass of the Sun. Okay, this mass is the m of the Sun, and we can cancel out both of these small m. So our formula will become m is equals to r cube into omega squared divided by the bigger g. So we know we'll have to figure out the angular velocity first to do this math. So how can we actually figure out the angular velocity? We know the formula of angular velocity is equals to 2 pi divided by time taken, and we know the time in seconds, right? We can write 2 pi divided by, and we will get the value of angular velocity as 1.99 into 10 to the power minus 7 radian per second. So we will basically put this value right here in the angular velocity portion. Okay, so basically to get the m, we will write m is equals to, they have given us the radius, right? Did they give us the radius? Yes, they have given us the radius. So we will write 1.49 into 10 to the power 11 cube multiplied by 1.99 into 10 to the power minus 7 squared divided by the g, and we know the value of g is 6.67 into 10 to the power minus 11, which will give us a value of m as 1.96 into 10 to the power 30 kg, which is basically the value that they have asked us to show. We can write the answer as 2 into 10 to the power 30. So basically this is going to be our final answer. Now moving on to the part B, it says a television program channel claimed that the gravitational field strength at the surface of the sun is 28 times the gravitational field strength at the surface of the earth. Deduce whether this claim is correct. Now this question is a very common question. This type of questions are generally asked in Gen 20 in every physics unit 5 sessions. If you want, you can watch my October 24 and May 24 paper solving videos as well, which I'll be providing in the description box, as well as the prediction video of the Gen 2025 exam and multiple choice questions videos for the Gen 2025 exams. All of the physics unit 5 videos that I have made, I'll be providing in the description box so that you guys can watch and know about the trends of the questions that are actually coming in the exam. And the most recent 3 papers, the May 24, October 24 and this Jan 25 paper, will be uploaded in my YouTube channel. You can watch in the description box. I will be providing in the description box. Now let's jump out of this question. It says someone is bigger than the other one. When someone is bigger than the other one, the best possible way to show that, yes, if it's saying that sun is 8 times greater, right? Sun is actually 28 times greater. The best possible way, how is it greater? Its gravitational field strength is greater than the gravitational field strength of the earth. So basically we will have to compare between the gravitational field strengths. So basically we know the gravitational field strength at the surface of the earth, right, which is 9.81. Now we will just have to figure out gravitational field strength of the sun and see whether it is 28 times greater than 9.81 or not. So to figure that out, before we will write the formula, it says 28 times. Someone is 28 times greater than the other one. So our first approach will be to divide the gravitational field strength of the bigger one, which is greater, divided by the gravitational field strength of the earth. We know the gravitational field strength of the earth is 9.81, and we will figure out the gravitational field strength of the sun and divide it by 9.81, and we will see whether it is 28 times or not. So now let's figure out the gravitational field strength of the sun. So we know to figure out the gravitational field strength, there is a very easy formula, which is gm by r squared, right? And we know g is 6167 into 10 to the power minus 11 multiplied by the mass of the sun that we have figured out previously, which was 1.96 into 10 to the power 30, divided by the r squared, and we know the radius, right? We know the radius of the sun that they have given us. They have given us the diameter. Actually we will divide it by 2 and then we will square it. So it will be 1.39 into 10 to the power 9 divided by 2, and then we will square this value. So by doing this, we will get the value of the gravitational field strength of the sun as 270.7 Newton per kg. Sorry for my bad handwriting. So we will put it right here and see whether dividing this one will get us this value or not. So 270.7. Whenever there is a bigger value, always put the bigger value in the numerator and the smaller value in the denominator to see whether it is that times bigger or not. So we will see that yes, it is 27.6. The value comes as 27.6. So we can say yes, the calculated value is consistent. Yes, it is 28 times 28 times 28 times the gravitational field strength of the earth. Don't write it like this, always write the full writing. I'm writing it like this. You're in, so the claim is correct. You should write the whole writing right here, that the gravitational field strength, okay, of the earth. Don't write simply like me. I'm just writing it like this to save time and not to make the video big, so that it doesn't get exhausting for you guys to watch the whole video. The question number 15 says the Millennium Bridge as shown is a suspension bridge for people to cross the River Thames in London. The bridge developed a large swaying motion when people walked across. So swaying motion here is meaning that it oscillates when the people walked. When the people walks, it oscillates. Dampers were fitted to the bridge to correct the swaying motion. We will have to understand the main objective of adding the dampers. The main objective of adding the dampers is it actually dissipates the energy by limiting the oscillation of the bridge. Explain the cause of the large swaying motion. So why does a large swaying motion actually occurs, and the effect of the dampers. So what actually the dampers does. So basically how the large swaying motion is caused. The large swaying motions means the large oscillation. A large oscillation means the bridge oscillating with a very high amplitude. Okay, why does it oscillates with a very high amplitude? The thing is, when the people actually walk, they set the bridge into oscillation, and that oscillation is called the driving. That oscillation actually has a driving frequency. Now if that driving frequency is equal to the natural frequency of the bridge also has a natural frequency, and when the people walk through the bridge is set into oscillation, and that oscillation has a driving frequency, and if that driving frequency is equal to the natural frequency of this bridge, then resonance occurs. And we know when resonance occurs, maximum energy transfer occurs, and when maximum energy is transferred to the bridge, it starts to oscillate with a very high amplitude, and then we use the dampers to reduce that amplitude of oscillation by dissipating the energy. So this is how the whole scenario works. This is a very common Edexcel levels physics unit 5 question that I think you should be able to answer. This is a A-star question. Now here is the answer that you guys should be writing like this to get all the 6 marks. Hopefully I was previously able to make you guys understand. Now it says when people walk, they set the bridge into oscillation with a driving frequency, and then resonance occurs because the driving frequency is equals to the natural frequency of the bridge, and there will be a maximum energy of transfer of energy to the bridge. When resonance occurs, there is a maximum transfer of energy, and when the maximum energy is transferred, the amplitude of oscillation of the bridge is maximum, and that energy is transferred from the bridge to the dampers, and when energy is transferred from the bridge to the dampers dissipate the energy and limits the amplitude of oscillation. So these are basically the 6 points that you guys will have to be able to understand and then memorize, because this is a A-star question and these questions are repeated again and again. Now let's moving on to the question number. Cepheid variable stars are used by astronomers as standard candles. What is meant by a standard candle? We know standard candle is a stellar object that has a known luminosity. Now the next part of the question says the luminosity of Cepheid variable stars varies periodically. Okay, it actually varies. The luminosity actually varies. There is a linear relationship between the period and the mean luminosity of a Cepheid variable as shown. So this is the mean luminosity divided by the sun. I mean the mean luminosity in terms of sun. And they have given us the period per days as well. All right, that's very good. Now in the next part it says the variation. We know the luminosity varies periodically, right? Now it has given the variation in luminosity L of this Cepheid variable star with time is shown basically. So the time, how the luminosity actually varies according to time, they have given us that thing. Now it says show that the mean luminosity of this Cepheid variable star is this much. So they're asking about the mean luminosity of this Cepheid variable star. Okay, so basically we'll have to figure out this mean luminosity from the graph, right? We'll have to figure out this mean luminosity from the graph. So to figure out this mean luminosity from the graph in the y-axis, we have to know the x-axis first, right? We will figure out the x-axis and then we will figure out the mean luminosity, as the mean luminosity, the corresponding value of this period will be the corresponding value of the mean luminosity. So first of all, we have to figure out the time period. But here they have given us the time taken. They have given us the time taken. So we will use this time taken to figure out the time period. Now the time period means the time it takes for one complete wave to pass, right? The time period is what that it tells. Now there is a variation in luminosity of this Cepheid variable. Now the luminosity starts from here, it goes, it becomes maximum and then it comes again back. So there has been basically this is one complete wave and then it again starts from here and goes here. So there is two complete wave, there is three complete wave and there is four complete wave. So basically as there is four complete wave, the luminosity varied four times. Actually the luminosity goes to its maximum value and then comes to its come to its minimum value four times. So basically for this variation of four times, for this luminosity to vary four times, it took 20 days. So as it took 20 days for to vary four times, now the time period will be how much days it takes to vary one time. So we will figure out t is equals to 20 days divided by 4, it will give us 5 days. So basically for one variation of this luminosity to go from this point to maximum and then coming to its point, this value is actually 5 days. It actually takes 5 days for it vary once. To vary once it takes 5 days, and this is what the time period is all about. The time period is all about how many hours or how many seconds or how many days it takes to vary once. This is what time period is. But they are the time take, but here they have given us the time taken for it to vary four times, as there is four complete wave right here. So we have got our value as 5 days, right? So if this is 1 2, this is going to be this is not actually a linear scale. No, this is actually a linear cell, my bad. This is going to be 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10. So basically our 5 will be right here. So we know at 5 this is the graph. So basically this is going to be our main luminosity. Our main luminosity is going to be 2000, and we can say the luminosity was in, the main luminosity is in luminosity of the sun. So we'll have to multiply luminosity of the sun with this 2000. We'll have to multiply luminosity of the sun with this 2000. So now let's do it. The main luminosity is equals to 2000 into the luminosity of the sun, which is 3.83 into 10 to the power 26 watt, which will give us a value of 7.66 into 10 to the power 29 watt. Now a question might arise in your mind, why did I multiply it with this luminosity of the sun? Because why did I multiply this 2000 with this luminosity of the sun? Because you guys can see right here, it is written mean luminosity per L sun. I can actually show this. It is like this, mean luminosity divided by luminosity of the sun, and we have got that the mean luminosity is equals to 2000. So if you write 2000 right here, so to make mean luminosity the subject, we will write mean luminosity is equals to 2000 into this luminosity of the sun, right? This is how we'll have to multiply the luminosity of the sun to figure out the mean luminosity, because mean luminosity per luminosity of the sun is this 2000. Okay, this is not actually the mean luminosity, this is mean luminosity per luminosity of the sun. So mean luminosity divided luminosity of the sun. Okay, we know speed is equals to distance divided by time taken, right? The distance covered per unit time. So distance covered per unit time, that's why distance is in the numerator and time is in the denominator. That's in the same way Main luminosity per luminosity of the sun means main luminosity is going to be in the numerator and luminosity of the sun will be in the denominator. That's why we have multiplied it with the luminosity of the sun. The next part of the question says, when viewed from the earth, the main intensity of the Cepheid variable is this. They have given us the main intensity. Now determine the distance of this Cepheid variable. We know the luminosity, right? We know the luminosity. Um, we know the intensity as well. If we got the luminosity and the intensity, figuring out of this distance is very easy, right? We can use intensity is equals to luminosity by 4 pi d squared. Okay, if we make d the subject, it becomes d square is equals to luminosity by intensity into 4 pi. So it will be 7.66 into 10 to the power 29 divided by 5.1 into 10 to the power minus 4, which is my intensity, into 4 pi. Okay, and as this is root over here, if we make this if this is square, as this is square right here, if we root over this whole value, if we root over this whole value, it will become d is equals to, which will give us a perfect value of let me check, it will give us a perfect value of 1.093 into 10 to the power 16 meter. Okay, this is basically our answer. Now the final will be 1.1 into 10 to the power 16, because the data provided, which is 5.1 to 10 to the power minus 4, is in two significant figure. That's why our final answer will be into a significant figure as 1.1 into 10 to the power 16 rather than 1.093, which is a 4 significant figure. Your answer should be the same as the data provided in the significant figure of the data provided. Now the question number 17 says that a graph shows the acceleration of an object varies with displacement x of the object from its equilibrium position. All right, it is moving from its equilibrium position. Now they have given us the graph, and the first question says, explain how the graph shows the mass is moving with simple harmonic motion. Now this question is very much common in every exam papers, but in the most recent January 2025 paper, the mark scheme points that the examiners have written is a bit different from the actual ones. Okay, the mark scheme points are a bit different from the actual ones. Now in simple harmonic motion, we know the formula of acceleration is acceleration is equals to minus omega squared x, right? So basically when the acceleration increases, the displacement also increases, but in the negative axis, because acceleration is directly proportional to minus x. Acceleration is directly proportional to minus x. So basically right here you can see, when the acceleration was increasing in the y-axis, the displacement was increasing in the negative axis. This is the positive axis, right? um, this is the positive axis and this is the negative axis, right? So it was increasing in the negative axis. So when acceleration was increasing in the positive axis, due to minus x, displacement was increasing in the negative axis, and it was going through the origin. So these are all the 3 points that you guys will have to explain, that the graph is a straight line through the origin with a negative gradient. Why negative gradient? Because a is directly proportional to minus x. Okay, if you make if you divide a by x, it becomes minus omega. So this minus omega is my gradient, right? The y-axis divided by x-axis is my gradient, and my here y-axis is the a and the x-axis is the x, right? It says hence the acceleration is proportional to the displacement from the equilibrium position. Yeah, both of them are proportional, because a is directly proportional to minus x. So basically a is directly proportional to x, and the acceleration is in the opposite direction to the displacement. Yes, when the acceleration is positive, the displacement is negative. When the acceleration is going positive y-axis, then displacement is going to the negative x-axis. That's why this is the 3 points that you guys should memorize. These are the 3 most recent mark scheme points of this question. It will be in the May 2025, October 2025 exam as well. Make sure to write these 3 points rather than the old mark scheme points. Now moving on to this question, it says calculate the maximum kinetic energy of the object. Now to calculate the maximum kinetic energy, we will have to take into consideration the maximum velocity. We will have to take into consideration the maximum velocity. For the maximum kinetic energy, we need the maximum velocity, so which is v max, and we know the formula of v max is a omega sine omega t. Now how it comes actually, this can be shown using one picture. Let me show you that picture. Here basically you guys can see when something moves vertically, the formula for the maximum velocity is v is equals to a omega sine omega t. And here when the velocity is actually maximum, at maximum velocity the sine omega t is equals to 1. This is something that we all know, right? And why is it 1? Because at the maximum part sine is always 1. Okay, at the maximum displacement, or sorry, at the maximum velocity the sine graph is always 1, or sine omega t is always 1. So now right here v max equals to a omega sine omega t. Now as this particular sine omega t is only 1, so we can write this v max formula as v max is equals to a omega. If you guys are facing an issue in this type of questions, you guys can check my most common slash important slash difficult physics 95 question paper solving video or questions video. On that video I have explained that particular part in real detail, and I have shown a very similar question to this one. So please go through that video because that includes few more important things as well. So the formula becomes v max is equals to a into w. So now we will have to figure out this a. So how we will actually figure out this a? Now let's move on to this graph. Okay, now let's move on to this graph. And now this amplitude is actually the displacement, right? Amplitude is the displacement, the maximum displacement is the amplitude, right? The maximum displacement is the amplitude. So now here we will have to figure out the maximum displacement, and we'll also have to figure out some of the few other things. Let's go through other more things. Now we know we'll also have to figure out this angular velocity, right? We'll have to figure out this angular velocity. Now how we will actually figure out the angular velocity? We know that this angular velocity is actually the gradient. This angular velocity is actually the gradient of this graph. So basically if we figure out the gradient of this graph, we will get the angular velocity, right? Now let's figure out the gradient. If we take this particular graph like this, okay, if we take this particular graph like this and we figure out the gradient, we know gradient is equals to, always gradient is equals to del y divided by the del x, right? Now we'll have to figure out the change in y-axis. Okay, the change in y-axis. So basically the change in y-axis, so this point is let me bring it right here. This point is 0.7, right? This particular point is 0.7, and this particular point is 1 point, and this is another point of the graph. So del y is going to be 0.7 minus this 0, right? This is the 0. So let's take this down as this as y2 and this one as y1. Okay, now for the x-axis we have got this one, which is for this particular line, which is minus 0.04. Let's take this down as my x1, and for this particular point it is 0.00. So we'll take this down as x2. Now let's figure out the gradient. So our gradient is going to be equal to, gradient is equals to y2 minus y1, right? So it is 0 minus 0.7 divided by x2 minus x1. So it is 0 minus 0.04, y2 minus y1 divided by x2 minus x1. Now our gradient value comes as minus 17.5 s minus 2. So this is what my gradient value comes, and we know the gradient is equals to minus w. And now if gradient is equals to minus w and we have got minus 17.5 s minus 1 is equals to minus omega, so our only angular velocity is going to be positive 17.5 s minus 1, because this positive negative gets cancelled out. So our angular velocity value is 17.5, right? So we can put it right here that our angular velocity is 17.5 s minus 1. So this is my angular velocity. I have got my angular velocity. Now I will also have to figure out my amplitude, and we know amplitude is the change in the displacement, right? Amplitude is the del x. Amplitude is actually the del x. So our del x was this one, right? The change in the displacement. So it was 0 minus 0.4, which was a value of, which is equals to a value of 0.04, which is 0.04, because the minus gets cancelled out. So this is my amplitude, or the del x as well. We know the change in displacement is actually the amplitude, right? In vertical simple harmonic motion. So basically My del x is 0.04. We have got my 0.04 as well. Now we'll just have to figure out the Vmax. The Vmax is equals to 0.04 into 17.5, which will give us a value of sorry, this is the, sorry, my bad. There is a difference because my bad, there was a simple mistake actually. This wasn't only minus w, it was minus omega squared. Okay, this was minus omega squared, so it will be omega squared is equals to 17.5. So omega will be equal to root over 17.5 s minus 1, so it will be equal to 4.18. Sorry, my bad, there was a simple mistake. I have forgotten to written that it was omega squared, because we know acceleration is equals to minus omega square x. If we divide a divided by x, it still remains minus omega square, right? So now we will have to change this part. So omega is equals to 4.18. So we'll multiply 0.04 with 4.18. Okay, we'll multiply 0.04 into 4.8. So it will be like this. It will be 4.18. So this will give us a velocity value of 0.167 meter per second. So we have got our maximum velocity, and we will have to figure out, the question asked us to figure out the maximum kinetic energy. So to figure out the maximum kinetic energy, we will multiply the mass with the v squared. So kinetic energy maximum is equals to half into 0.25 into 0.167 squared, which will give us a value of 3.5 into 10 to the power minus 3 joule. The calculator value will be 3.486, but as the data provided was in two significant figure, that's why we have written our answer in two significant figure. Okay, now in the next part, this was a bit tricky, but this was the most easiest question, but still students messed up in this question. It says sketch a graph on the axis below to show how the kinetic energy of the object varies with displacement x. Now first of all, I'm going to draw the graph and then I will explain to you guys. Okay, the graph will be somewhat like this. The graph will be exactly like this, and this will be the maximum, this will be the negative amplitude, and this will be my positive displacement. Actually, I mean the positive x displacement and the negative displacement. Why I have written the positive displacement and the negative displacement? Because let's think it of like this. Let's draw a spring. Let's draw a spring right here. This is the spring, okay, and this is the mass. Now this is the mass. Now if you take this mass downward, from its equilibrium position, let's say this is the equilibrium position, and the mass will go down. Now when the mass is going down, its displacement is increasing, right? Its displacement is increasing. Its displacement will be positive. When it is going down, its displacement is increasing, and when it is going down, its displacement is increasing, but its velocity is decreasing, right? Why its velocity decreases? Because it encounters kinetic and it encounters resistance, or it encounters air resistance or resistive forces acts on it, so its kinetic energy decreases when it is going down. Its kinetic energy basically decreases. Okay, now from zero, it was the zero. From zero to positive displacement, its kinetic energy decreases. Why? Because greater amount of air resistance is acting on it, or just air resistance acting on it. Air resistance takes out its energy, or the mass needs to do work against the kinetic energy. Sorry, the mass needs to do work against the air resistance or the resistive forces. That's why it loses its kinetic energy, and that's why its kinetic energy is decreasing from 0 to 0.04. But from 0 to let's say from minus 0.04 to 0. Now let's look at this position. Why does the kinetic energy increases in this part? Now if we move, this was from the equilibrium position to a positive. This was at positive, let's say this was at positive 0.04 displacement as it has gone down. Now at negative 0.04, we will squeeze the spring. Okay, so now it is going like this in the opposite direction. Now here it is minus 0.04. The displacement was 0 right here, positive right here, and negative right here. So as it is going upward, when you will make it fall, now it will accelerate downward, right? Why it will accelerate downward? Because weight is acting on it, right? The gravitational force is acting on it, so it will accelerate downwards. So when something accelerates downwards, its velocity increases. That's why the kinetic energy increases right here. when it is coming from minus 0.04 to 0. When it is coming from minus 0.04 to the 0 position, at that time it is accelerating. It will be accelerating, or basically its velocity will be increasing, right? When something falls, its velocity increases. Still there will be a resistance acting on it, but still its velocity will increase, and that's why the kinetic energy is also increasing. That is the main explanation of this whole graph. Hopefully you guys have understood this one. This was a bit tricky. None of the students could answer, only a few of them could answer, but this was very easy, yet students couldn't answer. So make sure you are understanding it completely. Now let's move on to the next question. Now the question number 18 says the diagram shows dark line in the continuous spectrum of electromagnetic radiation from the sun. Atoms in the outer region of the sun absorb electromagnetic radiation. This produces the dark line in the spectrum. Yes, the dark line is always produced when they are absorbed. Explain why electromagnetic radiation is only absorbed at some wavelengths. Why it is not absorbed at different wavelengths. It is absorbed at a particular wavelength. Basically, this is an AS physics question. Let's go through the whole topic right here. We can go through them in real detail. You guys can see that electrons have discrete energy levels. This is first, this is second, this is third, this is fourth. Now, to jump from the ground state to the first excited state, okay, you guys can read this one. Energy level is the discrete energy that an electron can have. So electron have discrete energy levels. Okay, first, second, third, fourth, fifth, many different energy levels. If you look at the diagrams, you will see all the energies have negative values. Here all the values are negative. This is because they represent the energy required to cause a change in the energy level. For instance, an electron at ground state would require 10.2 volt of energy to move up to the first excited state. So from ground state to first state, to move from the ground state to first state, it will require 10.2 electron volt of energy. Now how do we actually figure out this 10.2? Because minus 3.5, this is final and this is initial. So if you minus final minus initial, so minus 3.5 minus 13.6 will give you 10.2 electron volts. So that is how it works. This means that an electron at the ground state will only absorb a photon of energy 10.2 electron volt. Okay, if it has to move up to the first excited state, it will have to get this 10.2 electron volt. The ground state is the lowest energy level of an electron, and the ionized state, this is the ionized state, it is the highest, is the state where an electron breaks free from the attraction of the nucleus. This is not important actually for you. It should be clear by now that an electron will absorb a photon to move up to a higher level. The electron will actually absorb a photon to move from the ground state to the first excited state. And if the photon has 10.2 electron volt of energy, then it will move on to this first excited state. Okay, and will emit a photon, and the electron will emit a photon if it drops down to a low level. From first excited state, if it goes down to ground state, that means it has emitted a photon. Since energy levels are discrete, an electron will only absorb and emit photons with energies equal to the difference between the energy levels. Now the electron will only absorb 10.2 electron volt to move up from the ground state to the excited state, because it requires 10.2 electron volt to move from the ground state to the first excited state. It will never ever absorb 10.3 electron volt or 10.1. It will only and only absorb exactly the amount of energy it requires. Okay, that's why these are the 3 points that you guys will have to explain. I'm just giving you the mark scheme points. Just give me 1 minute. Here these are the points that electron energy levels are discrete. We have seen there are different energy levels. The first excited state, second excited state, and there is the last fifth excited state as well, and then the ionization energy. Now a photon is absorbed with energy equal to the difference in the energy between the two energy levels. We have seen, right, that was 10.2 electron volt from the ground state to the first state. The difference in the energy levels was 10.2 electron volt. Only certain energy level transitions are possible, so only some wavelengths are absorbed. As only 10.2 will be absorbed, they will only take 10.2. They will never ever take 10.3 or 10.4. So as only this certain energy level transitions are possible, only this 10.2 or the another one may be 13.4. So it will never ever be greater or less than 13.4. So this is exact points, right? So as these exact energy level transitions are possible, so only some wavelengths are absorbed. Not all the wavelengths are absorbed. Only the photons which have this amount of energy will be absorbed, not all of them. Okay, if a wavelength has, let's say, 10.3 electron volt of energy, he will never ever be absorbed. So that's why the photons which have this exact amount of energies will be absorbed. That's why only some wavelengths are absorbed, or we can say some photons are absorbed. Okay, hopefully you guys can understand, but for this question you will have to write wavelengths rather than writing the photons. Now let's move on to the next part of this question. It says the sun rotates on its axis. The diagram shows the sun rotating at its equator. So it is rotating on its axis. You will have to understand this word. Now the sun is rotating on its axis. One of the dark lines in the spectrum occurs at a wavelength of 589 meter. So basically it is the dark lines in the spectrum occurs. Okay, all right, this is the spectrum that they're saying about. Radiation is received on earth from opposite ends of the sun's diameter. So it is coming from the opposite ends. There is a difference between the wavelength of radiation received from opposite ends. So basically if they are coming from opposite ends, the wavelength that is received has a difference. Both of them will give different values due to the sun rotating about its axis. Okay, let's say you are getting from right here and here. So from both the parts, the wavelength that you will be getting is different, because if this one is moving into this direction, I mean, if this part is going backward, this part is coming forward, right? Because this end is going backward and this is going forward. So if let's say the earth is at the back end of the sun, so this part will be moving towards the earth and this part of the sun will be moving away from the earth. So this will be red shift and this will be blue shift. So both of them are occurring. That's why there is a difference in the wavelength at two ends of the sun. Okay, the difference in wavelength is this. So this is the difference that they have given. Now this difference is between the wavelengths of them, but we only are concerned about the difference, the del, and this is basically the del lambda. Okay, they have given us this as the del lambda. All right, now our website states that its equator, sun rotates once every 27 days about its own axis. All right, so all right, they have given us the time it takes for the sun to rotate once every 27 days. They are saying that it rotates once every 27 days. Assess the accuracy of this statement. They have given us the radius of the sun and they have given us the time to convert this seconds into day. All right, so basically as they are asking us to see whether it is 27 days and they have given us the radius of the sun, they are indicating that we will have to use the formula which is v is equals to 2 pi r divided by time taken. Why are we using 2 pi r? Because this is the circumference of the sun and v is equals to speed is equals to distance by time taken. So it is covering the, as it is moving its own axis, so it is covering the circumference. So that's why we are writing 2 pi r by time. Okay, so v is equals to 2 pi r by time taken. So if we make t the subject, it becomes 2 pi r by v. So basically we'll have to calculate this v. All right, we'll have to calculate this v. And we know the easiest form to calculate the v is del lambda by lambda is equals to v by c. Now we have got this lambda value. This is our lambda value and they have given us this del lambda. So we can write the lambda value first, which is 589 nanometer, and the v's needs to be figured out, and c is 3 into 10 to the power 8. We will just need to write this del lambda right now. So where we'll get the del lambda? This is the del lambda that they have given. This is the difference in the wavelength. So this is the difference in wavelengths of both the ends, this end as well as this end. But while figuring out this, we only need the one end. We only need one end. This value includes both the ends, but we only need one end. That's why we'll be dividing it by 2. It will become 7.94 into 10 to the power minus 3 divided by 2. Now a question might arise in your mind, why did I divide it by 2? Because here we are asked to assess whether the sun rotates once every 27 seconds, and here we can see one side of the sun, okay, moves towards the earth. If the, let's say the earth is at the back end of the sun, the earth is, let's say, right here at the back end of the sun, so this part of the sun is moving towards the earth and this part is moving away from the sun. So this is here blue shift and this is here red shift. So the total change in wavelength, this is the total difference in wavelength. Okay, this is across both the sides. This is across both the sides. This del lambda is across both the sides. But you have to remember one thing, this includes both the sides, but here in this del lambda we only need one side. Okay, here we are only interested in the speed of one side of the sun. Here we are only interested in the speed of one side of the sun. That's why we have divided by 2, because this del lambda includes both the side of the sun, but to figure out this v we only need one side of the sun. We are interested in one side of the sun, that's why we have divided by 2. Using this we will get the v value as let me check it. What is the value of the v? Comes as the value of v comes as 2.02 into 10 to the power 3 meter per second. So this is basically my v value, and I can put this v value right here, and we know the radius has been given as 6.96 into 10 to the power 8, right? It is given as this radius will be like this. Let me convert this radius right here. This radius will be 6.96 multiplied by 6.96 into 10 to the power 8 meter, and this will be our v value. Okay, if you do this, our time period will be equal to 2.165 into 10 to the power 6 seconds. Now our answer has come in seconds. Okay, but our answer but the final answer needs to be in days. That's why they have given us the seconds in 1 day. So basically, if 8.64 into 10 to the power 4, this is 4 maybe, right? Yes, this is 4 seconds means 1 day, then 1 seconds will be 1 divided by 8.64 into 10 to the power 4 days, right? And this much seconds will be 2.165 into 10 to the power 6 will be equal to 1 into 2.165 into 10 to the power 6 divided by 8.64 into 10 to the power 4 days, right? Which will come as 25.06 days. So basically our answer has come as 25.06 days, whereas they have said about 27 days. So we can say it is small. Okay, we can say it is less. So we can say that 27 days was an overestimate. So 27 days was a straight overestimate. Now let's move on to the next part of this paper, which is the question number 19. Are you still stuck in chapter 1? Well, your exams are racing closer. You have watched thousands of videos on YouTube, but your marks are not moving. It's not you, it's the method. Let's fix it. Welcome to Exam Essentials, where every second counts and every session hits. You have seen our question solving walkthroughs, right? Now it's time to go all in. We offer 2 signature courses for A-level and O-level students. The first one is the High Impact Crash Course, which is basically launched 5 to 6 months before every exam session. Whether it's May 26, October 26, or any future sessions, this course is your fast track to results. For the upcoming October 25 and the January 2026 sessions, our High Impact Crash Course will be starting from June 1. So book your seats as soon as possible. Now the second course that we always offer is the complete 1-year course, designed for students preparing for May 26, October 26, January 2027 and beyond. To know more, check the description box or message us directly on WhatsApp or on our Facebook page Exam Essentials. Stop struggling, start scoring. You have seen us on YouTube. Now it's time the world sees you succeed. Your top grade is waiting. Let's go get it together. Now the question number 19 says a filament bulb contains argon gas to extend the lifetime of the filament. Alright. While the bulb is off, the argon gas inside the bulb is at a temperature of 290 Kelvin. So the temperature is 290 Kelvin. The pressure of the argon gas inside the bulb is 75% of the atmospheric pressure. Alright, the pressure is 75% of the atmospheric pressure. They have given us the atmospheric pressure. So we can just do 75 divided by 100 with this atmospheric pressure to get the pressure of the argon gas. Okay, They have given us the volume. They have said calculate the number of argon atoms in the bulb. We know the formula, right? We know the formula. PV is equals to NKT, right? They have given us the temperature, and we know K is a constant. We know the value. They have asked us to figure out the N. They have given us the pressure and also the volume. Now it becomes really easy to answer this question. It's a freebie actually. So basically N is equals to PV by KT, right? And we know pressure is 75% of the atmospheric pressure. So we will write 75 by 100 is actually 0.75 into the atmospheric pressure, which is 1.03 into 10 to the power 5 multiplied by the volume 1.25 into 10 to the power minus 4 divided by the KT, and we know K is a constant which has a value of 1.38 into 10 to the power minus 23 joule. Oh, actually we don't need to write this. Multiplied by the temperature in Kelvin. They have given us the temperature in Kelvin as well. If in your question paper it is not given in Kelvin, make sure to convert it in Kelvin in your exam session. So our value will be equal to 2.4 into 10 to the power 21. Okay, and we can write it as 2.41 as well. No issues because the data provided was in 3 significant figures. So the answer will be 2.41 into 10 to the power 21 is the answer. Now moving on to the next part, it says when the bulb is on, the pressure on the argon gas is 83% of the atmospheric pressure. So this is basically the pressure on the argon gas when the bulb is on, and this pressure was normally the pressure on the argon gas, okay, inside the bulb, but it is when the bulb is on. The manufacturer states that the temperature of the gas inside the bulb is about 60 degrees Celsius while the bulb is on. S is whether this statement is correct. Now whenever you will be given a question in B part or C part, always relate this question to the previous part of the question, which was this part. Here, to figure out whether this statement is accurate, this statement says about the temperature. The statement says about the temperature. Now the only formula that is related with the pressure and temperature is PV is equals to NKT, right? PV is equals to NKT, and we know that pressure is directly proportional to temperature. Pressure is directly proportional to temperature. Now when the bulb is on and when the bulb wasn't on, at between these two times, the volume, the number of molecules, and this K value, all of these threes are actually constant. All of these threes are constant. Both of them is the same whether the bulb is on or the bulb is not on. So we can say pressure is directly proportional to temperature, or we can say pressure is equals to time. So the pressure is equals to time for 1 as well as the pressure is equals to time for 2. The 2 means when the bulb is on, and the 1 means this part when the bulb wasn't on. Okay, so we can write P1, we can write P1 divided by T1 is equals to P2 divided by T2. We are just writing both of them. Okay, we are just writing both of them, nothing else. Because if we write it like this, we can also write it like this actually. We can actually write it like this. This is the same math that I have explained in my common questions video. Watch that. So we can write P divided by T is equals to NK by V, and this as a whole is constant, right? This is P1, this is T1, and this is the same for P2 and T2. So we can say both of these are equal. So P1 by T1 is equals to P2 by T2. Now we'll have to figure out the T2 actually, the temperature when the bulb is on. This is the temperature when the bulb is on, right? So T2 is equals to P2 by P1 into the temperature of 1, right? So the pressure of 2 was 0.83 of the atmospheric pressure, and it was 75 of the atmospheric pressure. So the atmospheric pressures will be get cancelled out, so it will be only, we can write this P2 as 0.83 and this P1 will be just 0.75 multiplied by the atmospheric pressure multiplied by the atmospheric pressure. Now these two atmospheric pressure will get cancelled out as both of them are the same, so we can actually omit them. Rather than writing the pressures, we can only write 0.83 by 0.75 into the temperature of 1, which was the temperature of 1 was 290 Kelvin. So we can just write this down, 290 Kelvin. This will give us a value of temperature of 2 as 321 Kelvin. Now the answer is in Kelvin, but the answer needs to be, the final answer needs to be in degree Celsius. So if we convert in degree, it will become theta is equals to 312 minus 273, which will give us a value of 48 degree Celsius. Okay, so this degree Celsius is smaller than this, so we can say 48 degrees Celsius is less than 60 degree Celsius. So the statement is wrong, right? The statement is wrong. This type of maths are very common, where you guys will have to make one of them a constant, because nkt is constant right here, sorry, nk, and this volume is constant whether the bulb is on or off. That's why we have written p1 by t1 is equals to nk by v, and this is the same for both when the bulb is on or the bulb is off. Okay, this is the same for both, because the volume doesn't change whether the bulb is on or off, and the nk also doesn't change whether the bulb is on or off. That's why both of them will be constant, and that's why we have written p1 by t1 is equals to p2 by t2. Now here, while the bulb is on, radiation is emitted by the filament. The radiation has a peak power output at a wavelength of lambda max of 1100 Newton meter. So this is the maximum, this is the wavelength at which maximum power output comes. Okay, this is the wavelength at which maximum power output comes. So this can be written as, we know there is a formula which is lambda max T is equals to 2.898 into 10 to the power minus 3 meter Kelvin, right? This is the formula. Now we have got the lambda max as 1100 nanometer, so we can write it down like this: 1100 into 10 to the power minus 9, and we know this value as well. We can easily figure out this temperature, right? We can easily figure out this temperature. The temperature will be just equal to 2.898 into 10 to the power minus 3 divided by the value. So it will be just 2.898 into 10 to the power minus 3 divided by this lambda max value to get the temperature, and that value of the temperature will be equal to 2635 Kelvin. Okay, we have got the temperature value. Now the next question says calculate the power output of the bulb, and they have given us this surface area. We know the power output of the bulb is actually the luminosity. How brighter the bulb is, or how glowing the bulb is, the power output. The greater the power output, the more will the bulb glow. So basically that glowing part is the luminosity, and we know the formula of luminosity is 4 pi r squared sigma temperature to the power of 4. Now they have given us the surface area, and this surface area includes this 4 pi r squared part, because this is the surface area, right? So we can rewrite the formula as area into sigma into temperature to the power of 4. So we have got our area as 1.55 into 10 to the power minus 5, and our sigma value as 5.67 into 10 to the power minus 8 multiplied by this temperature value to the power of 4. So 2635 to the power of 4, which will give us a value of 42.4 watt. This is basically our power output, or which is the luminosity. You guys will have to understand that luminosity means the power output, because the greater the power output of a bulb is, the greater the bulb will glow, and the greater will be its luminosity. The next part, it says suggest why the actual power output of the bulb may be lower than the value calculated. Now the actual power output of the bulb will be lower because this power output will be the power output from the internal part of the bulb. This is the power output of the internal part of the bulb. But when this output is given, some of this energy from the power output of the bulb will be absorbed by the outer surface area, which is the glass of the bulb. The glass of the bulb will absorb a little bit of energy. So that's why the actual power output of the bulb will be a little bit smaller than this theoretical power output of the bulb. Okay, the reason behind that is because some energy will be absorbed by the glass of the bulb. There is a glass of the bulb, right? That glass of the bulb will absorb some of the energies. So basically we are done with the question number 19 as well. Now let's head towards the question number 20. Now the question number 20 says 50 years ago, Henry Petrie developed a device for the kitchen that produces instant boiling water. A modern version is shown. Alright. The system consists of a small tank connected to the water supply. Water in the tank is heated under pressure at a temperature of 110 degrees Celsius. When the water flows out of the tap, the temperature falls to 100 degrees Celsius. Okay, because there is no more pressure there. When water enters the tank at a temperature of 12 degrees Celsius, an electrical heater increases the temperature of the water to 110 degrees Celsius. So it uh, goes inside with 12 degrees Celsius, and then there is a heater which increases the temperature to 110 degrees Celsius. So from 12 to 110 degrees Celsius. The water does not boil because it is under pressure. So basically the temperature is increased by exerting pressure from 12 degrees Celsius to 110 degrees Celsius. Calculate the time taken to heat a full tank of water to 110 degrees Celsius. So basically they have asked us to figure out the time. Okay, they have asked us to figure out the time. So basically as they have given us to figure out the time, basically the energy needed, the energy is required to transfer to increase the temperature from 12 degrees Celsius to 100 degrees Celsius, right? So energy is required, and there is a formula which relates both energy and time taken, that is power. So basically we will do the math using that formula, which is power is equals to del E by T, right? So if we make T the subject, as we will have to figure out the time taken, we will make time is equals to del E by P. Now here we will need the power as well as the del E, the change in energy, or I mean the energy transferred. The energy transferred to increase the temperature from 12 degrees Celsius to 110 degrees Celsius. When we transfer energy to change the temperature, we use the formula del E is equals to mc del theta, right? So here the formula will be T is equals to mc del theta divided by the power formula. The power is provided by the electrical heater to increase the temperature, right? So it will be voltage into current. So here we need the mass. So we will get the mass. They didn't give us the mass directly, they have given us the density and the volume. So we know density is equals to mass by volume, and mass is equals to density into volume. So density will be right here, 997 multiplied by the volume, which is 3 into 10 to the power minus 3, multiplied by the C, which is the specific heat capacity. We know our specific heat capacity is 4180 that they have given us, multiplied by the del theta, and we know the del theta is 110 degrees Celsius from 12, right? 110 minus 12, so we can write it like that. We have to actually convert it into Kelvin, but converting both of them will have to include 273. So rather than converting into Kelvin, we can just write this down. The math will be the same. There will be no difference, because adding 273 to this one and to this one doesn't make any difference in terms of while subtracting them. Okay, so we can write 110 minus 12, 110 minus 12 divided by the power, and we know the power will be voltage into current, as they have given us the voltage into current. So 230 into 12.6. So this will be our value, and time will be equal to 423 seconds. So this is going to be our answer. Okay, this is basically going to be our, sorry, my bad. This is going to be our answer. Okay, now let's move on to the next part. It says the average rate of energy transfer from the tank to the surrounding is 9.5 watt. So this is the average amount of energy that is transferred from the tank to the surrounding. All right, energy, rate of energy transfer, rate of energy transfer. What does rate of energy transfer mean? The other word of rate of energy transfer is power, because we know power is equals to energy divided by time taken, and when there is time, we know this is rate of energy transfer. Energy divided by time means rate of energy transfer. Rate means it includes the time. So in other words, average rate of energy transfer means average power. So they have given us the average power as 9.5 watt, and this unit also shows that it is talking about the power. Now the next part says the full kettle contains this amount of water. Now this meter cube shows that this is talking about the volume. Have a look at the units, okay, to figure out what they are actually talking about. It takes 180 seconds to bring a full kettle water to 100 degrees Celsius. All right, so to bring or to increase or decrease the temperature to 100 degrees Celsius, it takes around 180 seconds. To increase the temperature of the kettle, okay, to 100 degrees Celsius, it takes only 180 seconds. All right, the kettle is used to bring enough water for 28 cups of water at 28 cups of tea to 100 degrees Celsius. So basically they use the kettle to bring enough water to 28 cups of tea. So for 28 cups of tea, they are using the kettle, but they didn't say how many kettles they are actually using to bring enough water for the 28 cups of tea. They have only said the kettle is used. They didn't say that one kettle is used or two kettle is used. They said only the kettle is used to bring enough water for 28 cups of tea. So basically we will also have to figure out the number of kettles that they are using to bring enough water for 28 cups of tea to 100 degrees Celsius. A reviewer compared the energy transfer from the tank to the surrounding in 24 hours with the energy transferred by the kettle to make the tea. So basically they are comparing this energy transfer of the tank with the energy transfer of the kettle to bring those 28 cups of tea to 100 degrees Celsius. They are comparing both of them. The reviewer claimed that the energy transfer from the tank would be greater than the energy transferred by the kettle. So this is what he is thinking. So they are asking assess the validity of the claim. So to assess the validity of the claim, as they are saying that the energy transferred from the tank is greater than the kettle, we'll have to figure out both the energy transfers. We'll have to figure the energy transfer of the tank as well as the energy transfer of the kettle. If we can figure out, then we can say whether tank is actually better or tank is actually greater than kettle. This is how we'll be able to validate the claim. So now use all the data provided and let's jump on to figuring out the energy transfer of the tank and then the energy transfer of the kettle. Now we know power is equals to energy into time taken, right? So the power is given as 9.5 watt. And did they give the time? A river compared the energy transfer from the tank to the sun in 24 hours. So they are comparing that the time it take was 24 hours. So we know power is equals to energy divided by time taken. They have given us the power as 9.5 watt and they are doing this experiment for 24 hours. So we have got the time as well. So the energy transferred can be figured out easily for the tank by multiplying the power into time. So energy transferred from tank is equals to power into time taken. Our power is 9.5 multiplied by this 24 hours. This 24 hours needs to be converted into seconds. We know 24 hours, each and every hour is 60 minutes. So we will multiply each hour with 60 and we know each and every hours is 60 minutes and each and every minute is 60 seconds. We will multiply it again with 60. This will give us a value of 8.21 into 10 to the power 5 joule. We have calculated the energy transferred from the tank. Now it's our job to figure out the energy transferred from the kettle. Then compare between them that whether the tank is actually greater than the kettle in terms of transferring the energy. So now let's figure out the energy transferred by the kettle. Okay. Now here it is quite difficult to understand because the first thing that I can see right here is they didn't mention how many kettles they are using to bring their 20 cups of tea to 100 degrees Celsius. They have only said that the kettle is used, but how many numbers of kettles? They didn't mention anything about that. Okay, but they have mentioned a full kettle contains 1.4 into 10 to the power minus 3 meter cube of water. Okay, so but they have mentioned about the 28 cups of tea. Now let's figure out the volume of that 28 cups of tea. So one cup of tea has a volume of this much. So how much will 28 cups of tea have? So we can figure out volume of 28 cups of tea is equals to 3.5 into 10 to the power minus 4 multiplied by 28, which will give us a value of 9.8 into 10 to the power minus 3 meter cube. So we have figured out the actual volume of tea that they are working with. We have got the volume of tea. I'm sorry. We have got the volume of the tea. Now we have got the volume of that 28 cups of tea. Now the next part will be we know one kettle contains this volume of tea. If one kettle contains this volume of water, then the volume of water that they are working with this much. So this is the volume of water that they require and one kettle contains this volume of water. Now dividing the total volume of tea divided by the volume of tea contained in one kettle, if we divide both of them we can get the number of kettles right there, right? Basically total volume of tea used is equals to number of kettles multiplied by the volume of T in one kettle, right? If the volume of T can be accommodated in one kettle multiplied by the number of kettles that they are using, we can easily figure out the total volume of T that they are using. Now we have got our total volume of T that they are using as 9.8 into 10 to the power minus 3, because they are using 28 cups. They didn't say the volume. We had to figure out the volume because they said only the 28 cups. And we know the volume of T in one kettle is 1.4 into 10 to the power minus 3. Full kettle contains this amount of water. So this is this one was how much? This one was 1.4 into 10 to the power minus 3. Now we can easily figure out the number of kettles. The number of kettles can now easily figured out, right? We can just divide this value and this value. So it will become number of kettles is equals to, the number of kettles will be equal to 9.8 into 10 to the power minus 3 divided by 1.9 into 10 to the power minus 3. Sorry, this is 1.4, my bad. 1.4 into 10 to the power minus 3, which will give us a value of 7. So basically they used 10 kettles to bring these 28 cups of water. Okay, they have used 10 kettles to bring this 28 cups of water. Now they have given it, they have also mentioned right here, you guys can see that one kettle contains this amount of water, and it takes 180 seconds to bring a full kettle to 110 degrees Celsius. So if 180 seconds is required to bring one kettle to 100 degrees Celsius, then to bring 7 kettles to 100 degrees Celsius, it will require 7 into 180 seconds, right? So time kettle is switched on will be equal to 7 into 180. This will give us a value of 1260 seconds. Now we have got our time and we have got our power as well. The power of the kettle was 2600. Now we can easily figure out the energy transferred to kettle, or energy transferred by the kettle, which will be equal to the power into time. Our power was 2600, which was the power of the kettle right here, multiplied by the time 1260, which will give us a value of 3.28 into 10 to the power 6 joule. So basically we have figured out the energy transferred by the kettle as well as the energy transferred by the tank. Now we can see one thing, that this energy transferred from the tank is smaller than the energy transferred by the kettle, because it is 10 to the power 5 and it is 10 to the power 6. So the statement was wrong. It was saying the tank was greater, but in reality the kettle is greater. So we can say that 8.2 into 10 to the power 5 is less than 3.28 into 10 to the power 6. So the claim is not valid. We can say the claim is not valid. So basically, alright, so let's solve the last question of this paper. It says promethium is produced by a byproduct of nuclear fission. An isotope of promethium PM147 decays by beta emission. The thickness of paper produced in paper mill can be monitored using beta radiation. So basically they will monitor the thickness of the paper. So basically maybe the thickness of the paper will be changed. Okay, the count rate recorded by the GM tube is a measure of the thickness of the paper. Yes, so basically the thickness of the paper will be varied. Explain why a source of beta radiation is suitable to monitor the thickness of the paper. Now why the beta radiation is suitable? Because we know beta radiation passes through the paper. Okay, they will pass through the paper, but if the thickness is increased, some of them will be absorbed. So by looking at the rate of detection in the GM tube, we can figure out how the thickness is working with how the thickness is affecting the count rate. Okay, so basically now let's bring in the answer. It will be like this. Sorry, my bad. Answer will have it. The paper will absorb some of the beta radiation, so the count rate will vary as the thickness of the paper varies. Okay, if the thickness increases, lesser amount of the count rate will decrease. If the thickness increases, the count rate will decrease because more number of beta radiations will be absorbed by the paper. Now moving on to the next part, it says in a particular paper mill, the PM source was replaced when the activity of the source has decreased to 0.75% of its initial activity. So it has become 0.75% of its initial activity. So basically, if its initial activity was, let's say, 100, now the activity has become 0.75% of that 100. 0.75 of its initial activity. So we can say 0.75% means divided by 100 of initial activity means multiplied by 100. So if we remove both the 100, so now it has become 0.75. So if the initial activity was 100, now it has decreased to 0.75. Okay, calculate the time that the source had been in use. This is a very easy 4 marks common question that is more or less in every exam paper, so make sure you're understanding it completely. Half-life of PM is given. If the half-life is given, we know T half is equals to ln 2 by lambda. We can figure out this wavelength because we know the half-life actually, sorry, my bad. We know the half-life. So basically lambda is equals to ln 2 by 2.62 years, which will give us a value of 0.265 years minus 1 because this years goes up. So basically we have got the lambda value and we know the formula is A is equals to A naught e to the power of minus lambda into T, and we know A naught is the initial value and the initial value was 100, right? But it has decreased to 0.75 e to the power of minus lambda T, e to the power of minus lambda T, and we know the value of lambda as well. So if we divide 0.75 by 100 and then ln this side as well as ln this side e to the power of minus lambda, this lambda is 0.265 into T. Okay, if we do like this, this ln e gets cancelled out. We're only left with ln 0.75 divided by 100 is equals to minus 0.265 into time. So if we make T the subject, our answer will be 18.46 here. This is 18.46 here. Hopefully you guys will be able to do this math because this is a very simple math. I didn't do the whole thing just because you are in A2 right now, just giving the physics unit 5 exam. You guys should be able to do this one. So the answer is 18.46 here. Now moving on to the next part of the question, it says the most stable isotope of promethium is PM145. Calculate the binding energy per nucleon for nucleons in a nucleus of PM145. Give your answer in mega electron volt. Mass has been given and the neutron mass has been given as well. And the previous part we have missed actually this part. Sorry for missing that part. Let's do this part right now. Okay, now in terms of doing this one, you guys will have to be able to understand and know the electronic configuration of this beta, which is 0 minus 1. If this is 0 minus 1, then this will become 62 because 62 minus 1 is 61, right? And this will be 147 because 147 plus 0 is 147. Okay, so now let's move on to the previous part. It says the most stable isotope is this one, and calculating the binding energy per nucleons of the PM145. Was that question for PM145? It was for PM147. Okay, this one was for PM147 basically. Now for PM145, did they give us anything about the PM145? No, they didn't give us anything about the PM145 actually, but we will have to do one thing. That is, if the PM was 145 and the neutron mass has been given, if let's say this was PM 145, if this was 145, then this would have been 145 as well because 145 plus 0 is equals to 145. But here this would have been 59, right? This would have been 59. No, basically this will be the same because the proton number remains the same. This is something that we'll have to understand. that isotopes have a different numbers of neutrons, but their proton number remains the same. So here the proton number will be 61 as well. So it will remain 62. So the configuration will be 145 by 61 pm converts into 145 by 62 sm plus 0 minus 1 beta plus 0 neutrino. Okay. So now as we know the mass number, the actual mass number and the proton number, now let's move on to the question paper to do the actual question now. So it says the most stable isotope is this one. So calculate the binding energy per nucleon for the nucleon. So as they have asked us to calculate the binding energy per nucleon, we'll have to figure out the mass defect of this PM nucleus. We'll have to figure out the mass defect of this PM nucleus. So to figure out the mass defect, we know about the mass defect. Then when the nucleus is together, there is a mass difference with the nucleus. With, let's say, this, there are 145 nucleons, right? If you put 145 nucleus, so 145 nucleons inside a nucleus, if you put 145 nucleons inside a nucleus, their mass will be, let's say, 50 kg. Okay, their mass will be, let's say, 50 kg. But if you bring all these 50 nucleons and measure each and every nucleons itself, let's say you measure this one, you measure this one, like this, you measure each and every 50 of the nucleons and then add all their mass, you will get the value as 55 kilogram. Basically, their constituent particles have a greater mass than the mass they have when they are together inside a nucleus, because of this binding energy per nucleon, because all of these nucleons bind together, and to bind together they use this binding energy, and they have asked us to figure out this binding energy per nucleon. So to figure out this binding energy per nucleon, we'll have to figure out this mass defect. Now here in this scenario which I have seen, 55 minus 50 is equals to 5. This 5 is the mass defect or the mass difference between the constituent particles and the nucleus. So we have got the mass of the constituent, we have got the mass of the actual nucleus, which will be smaller, but the mass of the this is the mass of the nucleus, which is smaller, but the mass of the constituent particles will be way higher. The mass of the constituent particles will be way higher. So we'll have to add those 145 constituent particles mass together. Now we know it was 145 pm, so 145 of the mass number. If the proton number was 61, if the proton was 61, then the neutrons right there would have been 84, right? Because 61 plus 84 is equals to 145. So we'll have to calculate the mass of each and every protons, and we know the mass of one proton is 1.67 into 10 to the power minus 27, right? So mass of protons will be 1.67 into 10 to the power minus 27 into, how many protons were there? Actually there were protons of 61, so it will give us a value of 1.0187 into 10 to the power minus 25 kg. And the mass of neutrons will be, we know the mass of neutrons is the same, 1.66 into 10 to the power minus 27 multiplied by the 84, which will give us a value of 1.4065 into 10 to the power minus 25. So this is the mass of each and every neutrons and protons. So if we add both of them, we will get the mass of the constituent particles. Mass of constituent particles is equals to, if we add both of them, 1.0187 into 10 to the power minus 25 plus 1.4065 into 10 to the power minus 25, it will give a value of how much is that actually? That is 2.42519 into 10 to the power minus 25. So this is the mass of the constituent particles, and this was the mass of the nucleus, and the mass of the nucleus will be smaller than the constituent particles. So let's subtract both of them. So mass defect will be equal to, mass defect is equals to mass of constituent particles minus mass of the nucleus. So it will be 2.42519 into 10 to the power minus 25 minus, because both of them are in kg, so we'll have to convert this u into kg, and we know if we multiply u with if you multiply this u with 1.6 into 10 to the power minus 27, it will be converted into kg as well. So 144.913 into 1.66 into 10 to the power minus 27. So this will give us the value of mass defect, and the mass defect will be equal to 1.9634 into 10 to the power minus 27 kilograms. So we have got our mass defect. This is the actual mass defect, and the example which I showed you there, the mass defect was only 5 kilogram, right? That was actually the easier way to understand, but this one is the mass defect. As we have got the mass defect, we will actually have to convert this mass defect into joule. Okay, and then we will convert that into mega electron volt, because they have asked us our answer to be in mega electron volt right here. You guys can see they have asked us to convert this into mega electron volt. So to convert this kg into joule, we will multiply this kg with c squared. Okay, we know del E is equals to mc squared, right? So we multiply it with c squared. So 1.9634 into 10 to the power minus 27 multiplied by 3 into 10 to the power 8 squared, which will give us a value of just give them 1 minute to calculate. It will give us a value of 1.767 into 10 to the power minus 10 joule. So basically we have calculated it in joule. Now this joule needs to be converted into mega electron volt. So to convert this joule into mega electron volt, we will divide it by 1.6 into 10 to the power minus 19 into 10 to the power 6. Okay, this will convert this into mega electron volt. This conversion is very important. Make sure you know this conversion. So this is the mega electron volt. This is the mass defect in mega electron volt. This mass defect in kg is converted into mega electron volt. Make sure you know this conversion. Knowing this conversion is very important. Okay, if you don't know this conversion, please comment down below. I will provide you with a video which will help you guys to understand this particular conversion. Now this is the total binding energy. This is the total binding energy. The mass defect is equals to this mass defect of 5 kg is the energy that these particular particles have used to bind themselves together or to bind with each other. But this is the binding energy. But the question said binding energy per nucleon. We know the total binding energy, and we know the number of nucleons is 145, right? We know the number of nucleons in the nucleus is 145. So we know the binding energy, and we know the nucleons is equals to 145. So binding energy per nucleon will be dividing the binding energy with the number of nucleons, which will be divided by 145. So if we divide the binding energy by the binding energy per nucleon, it will give us a value of 7.6165 mega electron volt per nucleon. So our answer will be 7.62 mega electron volt per nucleon. This will be our answer. The answer will be 7.62. So our answer will be 7.62 right here. So this one was a simple math which was in your book as well. So make sure to understand this math in real detail so that you guys can explain it to you guys can actually solve this question. Now right after completing this paper, we are done with the most recent January 2025 Physics Unit 5 paper. You guys can also go through the May 2024 and October 2024 Physics Unit 5 papers, which I have solved, and the solving video is right here in my YouTube channel. I will put those videos in the description box so you guys can actually search for the May 2024 Physics Unit 5 Exam Essentials solving video. And there is also a common questions video for the May 2025 exam that I have uploaded in my YouTube channel. Feel free to watch that. That video includes all the different and difficult type of questions that might be in your May 2025 or October 2025 exams, because it not includes only the October, it not only includes the common questions, it also includes the most difficult and the important questions in the last 5 years. So I have concluded all of them. It is a 3 hours video. Make sure to watch that completely to ameliorate your exam preparation just 6 or 7 years before the exam. And if you want to do classes under me, join Exam Essentials. I'm the founder of Exam Essentials and the A-Levels Physics instructor of Exam Essentials. So feel free to message at our WhatsApp number or at our Facebook page. Both the links are provided in the description box. Message at our WhatsApp number provided in the description box. Have a good day. Bye bye.